All right, let's look at the homework 2.1, problem number 8. All right, so we have the graph of this function y equals absolute value of x squared minus 36. All right, so we have that. And we want to describe x values at which the function is differentiable. All right, so differentiable just means that you can find a derivative. All right, so you can find a derivative, which means that you can find the slope of the tangent line. Right, so if it's differentiable, we should be able to find the slope of the tangent line, right? So if you look at the, for example, point like this, right? If you have a sharp corner like that or a cusp like that, then you can see that we're gonna have hard time sketching the tangent line or determining the tangent line, because tangent line could look like this, or it could be horizontal, or it could be looking like this, right? So when you have a sharp corner like that, we cannot identify a tangent line. So which means that if there's no tangent line, then we cannot find the slope of the tangent line, which means that the derivative, we cannot find a derivative, right? So the derivative does not exist when you have a sharp corner like that or here, like that, right? So, but everywhere else, it's a nice and smooth, so we can find the slope of the tangent line derivative exists. So when you have a smooth curve, then it's differentiable. But when you have a sharp corner like that, then it becomes not differentiable, right? So let's see which one is that. Right here, function is differentiable for all x except for -6 and +6, because -6 is right there and a +6. Right, this should be the right answer. All right, let's check the answer. All right, I came back and looks like we got the first question correctly. All right, explain your reasoning. All right, function is continuous. All right, you can see that there's no breakage. Even though there's a sharp corner, there's no breakage, so this function is actually continuous. All right, derivative does not exist at endpoints. Well, I don't know what they're talking about, endpoints, so this doesn't apply. Function is discontinuous at those points. I don't understand what those points. But there's no discontinuity, so we know that this can't be right. And graph has a cusp. Yep, there are actually two of them, right? So this should be correct too. Right, function is not defined at those points. Actually, function is defined everywhere. Right? Let's check the answer. We marked, actually, let's see, reasoning. Function is continuous. A graph has a cusp. Maybe graph has a cusp is the probably the reasoning for that, right? So let's check the answer. All right, I came back and looks like we got the second part correctly. I guess the first function is continuous is actually a correct statement, but however, that's not the reason why function is not differentiable. The reason why this is not differentiable is that you have a sharp corner, or they want to call it a cusp. So the graph has a cusp. All right, that's it. I hope that this was clear.